Welcome back. We've been looking at some data analysis tools when I'm working with just raw data, and we're working now with two variables. We're measuring at the same time, so each row in this data table would represent, in essence, a single measurement, just something that we did at the same time. I would like to relate them, or see if they're related is actually a more appropriate way to state it. The first thing I might do is draw a quick picture. So I'm going to highlight the data, go to Insert, and then I'm looking for an XY scatter plot. I just want to see real quick if they look like they're related. And they kind of do. In fact, I can see, at least in my mind, I can see that there might be a negative relationship, meaning that as one variable rises, the other variable falls. And that will show up in my covariance as whatever the number is that comes up as my covariance will be a negative number. Now, we will also see, and I think this is going to be a fairly tight relationship, except for this point right out here is going to mess up the tightness of the relationship. But yeah, another story, I guess. Let's just go in and see how Excel creates a covariance. So as usual, I'll just start typing and see what comes up. COV, okay, there we go. Covariance dot S, so for a sample, the dot P would be for a population. It needs two arrays, so I have two of them sitting right over here. Here's the one for the variable I'm calling X because I didn't want to have to rewrite percentage of homes with smoke detectors over and over again. The second array I'm calling Y, once again, because I didn't want to write home fire deaths per million of population over and over again. I can now look at the covariance, and the covariance, as expected, is a negative number. Now, the one odd thing about a covariance is it never tells me just how significant the relationship is, and so I look to a correlation coefficient to do that for me. So a correlation coefficient is R sub xy. This is the covariance divided by the standard deviation of each of these variables separately. So, you know, I could do a number of calculations and come up with information that I need to calculate a covariance, or I could just see maybe I have a correlation coefficient. Oh, look at that. CORRL returns correlation coefficient between two data sets. That's what I want. So let's, looking for array 1. I'm going to go get array 1. And then array number 2. Now the negative sign is going to stick with us. I'm not expecting that to change. But now what I'm expecting is some number between -1 and +1. You know, given I just said there's a negative sign, I guess I'm expecting a number between -1 and 0. What I'm really looking for strength of relationship is closeness to -1. This relationship is pretty strong. It's actually very close to -1. So I would say that this correlation coefficient shows there's a very strong relationship between the percentage of homes with smoke detectors and the home fire deaths per million of population. So the larger the percentage of homes with smoke detectors, the fewer the deaths per million. Okay, well, thank you. And these ideas are going to keep coming back to us over and over again, and they always look roughly the same. So kind of get used to the idea of correlation, covariance, etc., etc. Thank you, and have a nice day.